Hello all, welcome back. So today we're going to discuss on a different topic which is very much essential also. So let's imagine a notebook that doesn't just store your work but actually thinks with you. A notebook that can solve equations, generate circuits, analyze data, and even can assist you preparing your technical lessons like this one in real time. That's the power of Notebook LLM, your intelligent lab partner for modern engineering. So let's move ahead. So the frustration ends here. Traditional learning tools slow us down. We switch between tabs, lose track of our context, wait endlessly for cloud models, and the creative flow gets disrupted. So this notebook LLM help us to think with us. And what if your notebook could join you, and what if your engineering environment becomes your assistant? So learn into curiosity and energy. So moving into a new paradigm, AI inside your notebook is the future now. So Notebook LLM integrates AI reasoning and simulates intelligence directly into your notebook environment. So this notebook will help us, and it will code with us, it reasons with our equations, it simulates along our designs, and it writes our document automatically. So everything in one place, so no switching tabs, no context loose, and no downtime. So this notebook is really helpful for us. So it gives us live results, reasoning with advanced technology and smart documentation. Notebook LLM doesn't only answer, it shows us how and why. We type our question and it generates the maths, graphs, simulation, and explains the reasoning step by step. So your circuits come alive, your code becomes intelligent, and your learning becomes faster and more creative. So this is the future of the engineering education. So in the series Spotlight, or real-time example that we have done already in our channel, that you have already seen Notebook LLM in action, right? So our entire circuit simulation series were architecture and supported using it. From KVL to Thevenin and to dependent sources, Notebook LLM helps us to generate, simulate, and verify the concept, and saving our hours of effort, right? So this is the future of engineering, and here AI meets execution, and where the students stop struggling and start creating. So let's unlock the power of Notebook LLM together. So this platform not only helps the students but also researchers and educators, where we can accelerate our experiments and rapid prototyping. And for the educators, it helps in creating interactive learning experience and scale the personal guidance. And this will help each and every one of us to learn better and move into a new dimension. So let's unlock the power of Notebook LLM and see how this works. So let's see how Notebook LLM works. So let's type Notebook LLM in Google and then open the environment of Notebook LLM. So let's click on try Notebook LLM. So I have already created few notebooks. So let's start afresh. So let's consider another login where the Notebook LLM is not used already. So now we have an environment which whenever you click you will be finding this type of environment. So to start with Notebook LLM, so we can use this create notebook, a new notebook, and there are a few examples set here which you can try and check what are there, or what is the power of the Notebook LLM, or how we can generate different notebooks. So let's try creating new one. So now in this, first of all, what we have to do is we have to upload the sources. So this source can be anything. It can be Google Workspace, it can be information from Google Drive or the files that we stored in the Google Drive, or it can be website or YouTube, and we can also copy paste text, and we can also put our notes like PDF or Word files. So let us enter here videos from our YouTube channel, and let's see how the notebook can create the modified, or how it can lead us take us to the tool of new learning. So as you can see there, these are the videos, so we can get the links. So from share button we can copy paste the links. So like this we can take any video that we require. Yes, so to start with, suppose I am pasting a video here and insert it. So this will appear in this. So here it is already providing a name. So if you want, you can change the name also. So suppose, let us consider we are naming it as circuit analysis. So the name of our notebook is circuit analysis now. So we can add more. So like this we can input more number of videos or others contents. So as you can see here, so let me add few more videos and then we'll get back to what we can do with this. Okay, so we have added few videos already. So now let's see how we can add PDF or any other documents. So we have to just drag and drop here. So I have entered one of my slides, so which says it's electric circuits 2. So I have entered that in this sources. So now what we can do, so it has already collected the information and it has already gone through these videos, and it will give you the answers with respect to whatever is present in these videos and documents. So as you can see, like any other LLM models like ChatGPT or Gemini, this is the platform which is similar to us, right? So now here it already provides few questions to start our understanding or to start our lessons. So for example, like what schematics approach is used for writing KVL equations in multi-loop circuits. So if we put it, it will give us the answer based on these sources. So this is as simple as that. So as you can see, it gives the systematic approach of KVL equations for multi-loop circuits and mesh analysis. He defined loops, currents and directions, established KVL polarity conventions, write KVL equations for each loop, right? So it also shows how it can be done. As we have discussed in our video, it will give the content as it is. So we can directly learn from the videos and get the summarized output here. So for example, suppose if I want to learn something very basics, and considering that we don't know anything about the topic, so let's type like I am a class 2 student, teach me what is a circuit. So it will give you the answer accordingly. So let's see. As you can see here. So hello there, you are it's great you are learning about circuits. I can teach you what circuit is using simple ideas from the sources. Now coming to the directly points. So a circuit is an electrical network that is made up of different electrical parts, which we can different electrical parts all connected together. Think of it as a combination of different pieces connected in the same way. So what are the pieces inside the circuit? These are passive element, active elements. Then everything is under a closed path, right? So you can see it is a strong tool which will help you to learn better. Now it is not only that we can learn by writing questions. it has all other formats. For example, if you see this studio part, here you have different options available. So for example, suppose if you want to write or generate a report out of the sources, so you just click it here, it will generate a report. So let us consider we are requiring a introductory guide, suppose, or explanatory note. Okay, let's consider an explanatory note. So it will generate an explanatory note and it will appear here. See, it is generating. So along with that, we can also generate flashcards. So that flashcard will give you the informations in flashcard formats. We can also generate a mind map. So let's see what the mind map will give us. Along with that, after whatever we have learned, we can also generate a quiz out of it. So let's create a quiz also. And apart from that, we can also have a video overview of all these sources together. So let's see how the video overview will look like. And also we can generate a audio overview, which will be similar to like we are listening to a podcast. And not only that, we can have more options along with just listening to the audio. So we'll explore everything one by one. So let me first generate, and then let's move around what are its options. So as you can see here, circuit flashcards are generated. So let's see what are the flashcards shows. So here are the flashcards which will give us the informations point by point. So what are two primary conditions a circuit must satisfy for theorems like superposition, Thevenin norm to be applicable, right? So the network is considered if the parameters are such as resistor inductors do not change with respect to voltage and current. So this is what we discussed in our video before starting the theorems, that every circuit should be every circuit should be linear and bilateral. So those informations are given here. So as you can see, the flashcards are generated here, right? So we can expand this view. Also we can get it go back. Okay, so let's go to the studio again. So this is about the flashcards. Next, what we can see, yes, our explanatory notes are ready. So as you can see, this is the notes already generated. So instead of writing the notes from books or from taking information from different sources and then noting it down, it will generate everything automatically. And what we have to do, just go around and learn the things. So it will save our time to a higher extent, right? So now moving on to other features, like yes, this is the best feature which I like the most. So this shows the mind map. So as you can see here, prerequisites and methods of analysis of circuit analysis, which is our main source, and where we have discussed about these components like theorem for circuit solving, then network classification and elements, then different types of sources, then circuit analysis techniques. So if you see circuit analysis techniques, then we have here mesh analysis, node analysis, network conversions and division rules, right? So we have discussed all this. So in KCL, KVL we have based on KVL, then use loop current convention, clockwise, super mesh analysis, right? So this topic we have discussed. Similarly, if you move into KCL, then based on Kirchhoff's current law, then node definition, that the node is defined as whenever we have three branches, right? We have discussed this in our class. Then requires reference node, zero voltage potential. This also we have discussed. Convention current always moves out of the node. This is also one of the point that we have discussed. And then we have discussed super node analysis, which is mentioned here. So nodes connected by voltage sources, node resistances in that path, and not connected to the reference node, right? So and how do we solve that? By using KCL and one KVL equation. So this is what we have discussed in the videos, and everything is put here as a mind map. So next we have also discussed star delta conversions, then division rule, CDR and VDR, then how the CDR and VDR is done. Everything is shown here, right? So similar to this theorems of circuit solving, if we move into, then we have superposition, Thevenin, Norton, maximum reciprocity, right? And we have different validity conditions. Then network classification and elements. We have network elements, linear network, non-linear network, bilateral elements, unilateral elements, right? So everything is together mentioned here, and we can go back to the basic view like this. Okay, so this is as simple as that, and we can also download this. Okay, so this is another application. Then moving into I guess the quiz is ready. Yes, the quiz is ready. So now let's move into the quiz. So see, we have total 12 questions. We generate 12 questions, and we can determine the answer, give the answers, and check what we have learned based on the notes and based on everything that is provided by this notebook LLM. So for example, suppose for circuit analysis theorem like Thevenin Norton superposition to be built, what are the fundamental properties must network exhibits? So the network must be unilateral and non-linear. See, we already learned this, and this is a wrong answer, right? Then the network must be linear and bilateral. Yes, this is the condition. Let's see the other conditions, like network must be active and passive. The network must contain only independent and dependent sources. No, we have only one condition, right? So this is the right answer. So like this we can have different types of questions. So we can solve those and check whatever we are getting at the end of the quiz. So like this I am skipping the questions. So let's see here we have answered one question and raised right, and we have skipped everything. So that is why it's shown as 1 out of 12, right? So this is as simple as that, right? So we can generate quiz also. Now let's see if we have any other options that is ready with us. The video is getting generated. So we have discussed yes,
Welcome
the audio.
To the deep dive, where we really get into the essential research on complex topics and give you that high-octane synthesis.
This is the audio
to get
overview.
up to speed fast.
And today, we're strapping in for circuit analysis fundamentals. We're going way beyond basic Ohm's law here.
Right. If you're looking at circuits with multiple sources, loops all tangled up, maybe those voltage-controlled thingies.
We need a serious toolkit. Absolutely.
And that's our mission today. We want to give you the core requirements, the techniques, really, to handle those bigger networks.
We'll cover the conditions you must have for the big theorems to even work. Then practical sources versus ideal. And of course,
So we can make it interactive also. So you can see here. So let's see how we can make it interactive. So let's start the discussion.
Welcome to the deep dive, where we really get into the essential research on.
We can join this
and give you that
as a guest
high-octane
and
synthesis
then
to
get
up
our
to speed
answers.
fast.
And today, we're strapping in for circuit analysis fundamentals.
So let's
Going
see,
way
let's
beyond
join it.
basic Ohm's law here.
Right. If you're looking at
Oh, hey, I think our listeners got something to say.
So can you help me to make me understand what is a circuit?
that's a great fundamental question.
We love when you jump in. We were jumping straight into the complex stuff.
Okay, let's unpack this right at the beginning.
A circuit is simply an electrical network.
It's an interconnection of different electrical elements.
You're combining resistors, inductors, capacitors.
And crucially, voltage or current sources.
The key distinction is that a circuit provides at least one closed path.
That closed path allows current to flow.
Without that path, it's just a network of unconnected elements.
And we break those elements into two categories.
Passive elements, which absorb or store energy.
Like resistors, inductors, and capacitors.
And active elements, which
So
supply
see,
energy.
Those
this
are
is a
voltage
powerful
and
tool
current
which
sources.
So when we talk
help
about
us to learn
analysis,
everything,
we are trying
right?
to understand.
So using this, we can move into the discussion and join the podcast, right? So let's see what the video says to us. Yes, one more thing, we can also download everything whatever is generated here. So let us get the video generated and then we'll see. So give it a time. So finally our video is ready. So let's see how this will come out.
Have you ever stared at a circuit diagram that looks more like a plate of spaghetti and just felt completely lost? Well, today we're going to build the ultimate toolkit to untangle even the most complicated electrical circuits. We're going to turn that confusion into total confidence. Yeah? Take a look at a circuit like this. With all its loops and components, it can look pretty intimidating, right? It's that moment where you just think, where do I even start? And you know what? That's a totally fair question. But the answer isn't nearly as scary as you might think. So how do we tackle this kind of complexity? Here's the secret. There is no single magic bullet. It's all about having a system, a toolkit of powerful methods and knowing exactly which one to pull out for the job. And in this explainer, we're going to build that toolkit together, piece by piece. So here's our roadmap. We're going to start with the fundamental ground rules that make all our tools work in the first place. Then we'll explore the two main ways to see a circuit. Build up a set of awesome simplification shortcuts, and finally apply all of it to some of the trickiest circuits you'll ever come across. Okay, first up, the ground rules. Before we can even touch any of these advanced theorems, we have to understand the fundamental properties a circuit must have. Think of these as the non-negotiable rules of the game. The first rule is linearity. And all this
So
linear
like this
circuits
we have the
have
video
voltage.
here.
Current just means a component like a resistor works the same for a one-way
So as we have discussed in our video,
So here's
it
the
is
crucial
compiling
takeaway.
everything
Without
together.
linearity
See?
and bilateralism, conditions are met before we can confidently unlock the rest of our amazing toolkit. All right, with those ground rules
So we
in
can
place,
also
we can
download
now
this,
look at the two
as you can see
fundamental
here.
ways to see and
We can
analyze
also
any circuit, mesh and node analysis.
So we can also download this video and we can check this again and again. So this is the power of NotebookLM. So today's demonstration shows us how the learning can be faster, clearer and more enjoyable when the technology becomes your teammate. With NotebookLM, every circuit you draw, every equation you solve and every simulation you run is one step closer to innovation. So let's keep experiments and keep creating and keep learning, because the future of engineering is not coming, it is already here and it's powered by you and the Notebook LLM. So the Notebook LLM is not only replacing how we learn, it's redefining it. Together, let's move from repetition to innovation, from simulation to creation, and from learning to leading. So thank you for joining me on this journey, and let's continue to explore, innovate and make learning truly intelligent with Notebook LLM. So keep tuning into our videos and do share and subscribe so that you can get all the updates whenever it is uploaded. Thank you again.